Alright, so now what we're doing is going back to the stuff that we started yesterday, which is chapter 11, which is graphing trig functions. And I already did these notes with you, but then I went to Miss Tompkins and I actually grabbed the Smart Notebook notes so that you can see what we were doing. And so this is stuff that I've actually already gone over with you, but I just wanted to show you really quick. So the trig graphs, and then we use the unit circle to break up to create a table of values of y is equal to sine x in increments of pi over 4, which is the same thing as 45 degrees, and we did that yesterday. And we did that by making a table of those values and then going through and plotting them out on a set of axes. And let me just remind you about how that looks. You do pi over 4, and then, you know, once you've done that the first time, you don't really ever have to break it up into pi over 4 sections anymore. Normally we just break it up into pi over 2 or 90 degrees. So you have pi over 2, then you have pi, and you have 3 pi over 2 and 2 pi. So if this is the graph of sine, I'm just going to give you a little bit of a quick review. The sine graph starts at 0, and then I'm just going to make this our positive 1, and I'm going to make down here our negative 1. Whenever you're doing this, just make sure that you have, you know, you're skipping the same number of lines every time so that your increments are even. So sine starts at 0, ends at 0, goes through 0 in the middle. In between its first two zeros, we hit a maximum. In between the second two zeros, we hit a minimum of negative 1. And then your graph hopefully will be a lot more neater than mine because you're using a, you know, a pencil and paper. But this is what the sine curve looks like. Okay, so that's y is equal to sine of x. Then we did the same thing. Well, first we broke it up into 4 quadrants. You can see that each of the 4 quadrants have a quarter circle in them, and that's how we know that we break it up. The unit circle is actually divided up into 4 quadrants. What else? So sine starts at 0, ends at 0, goes through 0, halfway in between, blah, blah, blah. Then we were talking about there's one cycle of the sine curve, and a cycle is pretty much just you seeing one full curve. So you see the hill and you see the valley and then it stops. That's one full cycle, and we see one full cycle in every 2 pi radians. So the amount of space that it took for us to see one curve was 2 pi. The period of the sine function is 2 pi, so the period, one of the vocab words that we remember from yesterday, was the length of the interval needed to see one full curve. So that could change based on different equations. Then we did the same thing for cosine, and we graphed these functions. You go up here to positive 1, down here to negative 1. Go pi over 2, pi, 3 pi over 2, and 2 pi. Pi over 2, pi. Now cosine starts at its maximum, ends at its maximum. It hits its minimum right in the middle, so at pi. And then halfway in between each of those, obviously it's going to have to cross over the x-axis, so it goes through 0 there and there. Now cosine's a little bit flat up top, curves down, a little bit flat on the bottom, actually hits that point if you can help it on your paper, and it looks like that. That's cosine. And starts at its max, ends at its max, hits its minimum halfway in between, blah, blah, blah. Okay. We know that if we are graphing trig functions, you need to be in radian mode. You go to y equals, and then you're going to set the window, and your x is going to be between 0 and 2 pi, and you can actually type in the 2 pi, and it will turn it into a decimal for you. And then more than likely, your y is probably just going to be between positive 1 and negative 1. But, or negative 1 and positive 1. But it doesn't necessarily have to be. You're still going to see the graph. And then you graph it. Okay, now I think I made a mistake in telling you the wrong homework number. This is actually page 371 to 372. That's homework number 84. Okay, so that's the next one after the stuff that we just did together in those other videos. Homework number 84. And like I said before, number 4 right here, you're only doing 4a, and we only want you to graph between 0 and 2 pi. I think that the question says something else, but you're only graphing between 0 and 2 pi. So you should be completely capable of doing those 2 questions and handing that in for an assignment. So that's really, really good that you can get that out of the way already. Amplitude, period, and horizontal shift, we already did this stuff. I'm not going to go over it again except for to tell you that the A out front is the amplitude, and it's the absolute value of the amplitude, or the absolute value of whatever number is out there. So it pretty much just tells you how high the function goes and how low the function goes. Okay? Which function has a minimum value of -2? Well, it's going to be this one, because this has a max of 2 and a minimum of -2. And obviously all of those have different amplitudes. That has an amplitude of 1, that has an amplitude of 1, and that has an amplitude of 4. Okay? We did those. Then we were talking about B, which is the frequency, which is the number of full curves that you see in 2 pi radians. And sorry, my cat is licking my finger and it really tickles. Sorry. This is the number of full curves that you're going to see in 2 pi radians, and we did more examples like that. And the period is 2 pi over b. Find the amplitude, the frequency, and the period. I already went over every single one of these questions with you, so you can go back and look at those videos. I went over this as well, graph sine of x and negative sine of x in the same set of axes, and we figured out that negative sine of x is actually a reflection of y is equal to sine of x over the x-axis. Okay? Because what's the amplitude of both of those? Well, that has an amplitude of 1. That has an amplitude of 1 as well, because amplitude is the absolute value of that number out front. So the absolute value of 1 is the same thing as the absolute value of -1. Okay, so all it tells you is how high and how low the function goes. Alright, this is homework number 381 to 382. This is homework number 85. You should be perfectly fine with doing those as well, especially if you go back and look at that other video that I made you. Now we're just going to keep going, and we are still down here on the notes. We already did intro to trig graphs, and we're finishing up the notes on amplitude, frequency, and shift. So we did amplitude, we did frequency. Now we're going to talk about shift. So I'm actually going to use my calculator this time to show you this stuff. So using a graphing calculator, let's graph sine of x plus 3. And you want to always make sure that you are in radians. The only time you ever want to be in radians on your Regents exam is when you are graphing trig functions. Other than that, if you're in radians, then you will fail the Regents. And that sounds horrible, but it's the truth. So make sure you're in radians, go to the y equals, and we're going to graph sine of x plus 3. Alright, and then let's just look at the window that we're dealing with. Our x is between 0 and 2 pi. Let's make our y's just a little bit bigger so we can see what's going on. Let's make it between -5 and +5. And then let's graph it. So how does this affect the graph of y is equal to sine of x? Because we did y is equal to sine of x plus 3. Did I do plus 13? No, I did plus 3. Okay. I was losing my mind. Plus 3. Okay. So obviously something happened. It got shifted up +3. So that number when you're adding on the outside after the sine of x, that actually shifts you up and down. So if this had been sine of x minus 3, you would have been shifted that whole thing down 3. Now, what is the maximum and what is the minimum? Well, let me see. I can see that the maximum is right there, and that is up 1, 2, 3, 4. So the max is at 4, and the minimum is, that is at up 2. The minimum is 2. So let's think about this. Was the amplitude actually affected by shifting it up and down? Well, I've kind of been referring to the amplitude as how high and how low the function goes, and that's still the truth. It's just that we kind of have shifted the entire thing up 3. So far we only really know the amplitude to be the absolute value of that number out front. Here's another way that we can learn absolute value, or I'm sorry, the amplitude. The amplitude, or that number out front, can be defined as the absolute value of the max minus the min, so pretty much the highest value minus the lowest value, divided by 2. Now let's just see how that worked for this case. So we have a max of 4 minus 2 divided by 2, and you know that 4 minus 2 is just 2. The absolute value of a positive 2 is 2. 2 divided by 2 is 1. Okay? So that might come in handy in the future, but you can see that the amplitude actually did not change. It stayed a 1. It's just that we got shifted up. Okay, so this D that we have right here at the end, it is actually just representing the vertical shift. So vertical meaning up and down. Hopefully straighter than that line is. Up and down. If this number is positive, we're going up. If that number is negative, we're going down. Okay? Now we're going to take a look at what changes when we have x plus or minus a number that's inside here in the parentheses, because that might change it just a little bit too. So the graph of y is equal to sine of x plus c, or cosine of x plus c, is the graph of sine of x or cosine of x that has been shifted c units in the horizontal direction. So now we're talking about left and right. And this is something that you've already learned from all sorts of different functions, all sorts of different equations. And I'm going to kind of remind you of that in just 1 second. If c is positive, the graph is shifted c units to the left. Okay, so a positive number, it's kind of counterintuitive of what we think it should be. You think that when you're adding a number you should be moving to the right, but in this case we're actually moving to the left. And the same thing goes, if c is negative, the graph is shifted however many units over to the right. Okay? Let's see if we have an example of that. We don't have an example of that. But before I do this question, I kind of just want to summarize for you. So we have y is equal to a sine of, in parentheses, b x plus c, close those parentheses, plus d. Now we can do the exact same thing with cosine. I just kind of picked sine for absolutely no reason. This number right here, you need to remember this, you need to write this down, okay? This number is the amplitude. It tells us how high the function goes and how low the function goes. This b is what we call the frequency. Now the frequency tells us how many curves I'm going to see between 0 and 2 pi. Now that number never changes. It's always between 0 and 2 pi. The c has to always be inside of those parentheses, okay? So don't get confused about that. That c is the horizontal shift. Horizontal meaning left and right. And it's kind of backwards. It's backwards from what you think. So meaning if you're adding a number, then we're actually moving to the left. If you're subtracting a number, we're moving to the right. And then the last one, this d, is the vertical shift, going up and down, and that is what you think it should be. If you're adding a number, you're going up. If you're subtracting a number, you're going down. And I'm going to stop right here.